So let's say we start with a triangle. Okay, the first point of concurrency I want to talk about is the point where all the angle bisectors intersect. Okay, so the angle bisectors intersect at the point called Incenter. Okay, so here's the constructions for an Incenter. You're going to bisect each angle. So the way that we would do that on Sketchpad, we would select the 3 vertices for an angle, choose the vertex as the 3 points that form an angle, choose the vertex as your middle point, and then construct angle bisector. And now I'm going to change this to a thinner line here. Okay, so here is one of our angle bisectors, and then we just need to repeat this with another angle. Again, it doesn't matter which one. Choose the three points on that angle with the vertex as the second point, construct angle bisector. Okay, and then if we select the intersection of these 2 angle bisectors, this will be our Incenter. So I'm going to go ahead and label that Incenter. And the reason I'm labeling this as a word is now if I were to move my triangle around, that point will always, the label will follow it along. So you can actually see that is the Incenter. All right. Now, in addition to being called the Incenter is actually the center of a circle that can be inscribed within this triangle. Okay, so this is also allows us to find an inscribed circle. The way that we would take an Incenter and find the inscribed circle is if we knew that this was the radius, or I'm sorry, this was the center, what we'd want to do is we'd want to find a radius. In order for the circle to be inscribed within this triangle, the radius has to be perpendicular to the sides, all 3 of the sides. So if I select the Incenter and select one of the sides, and it doesn't matter which one, and I construct a perpendicular, so select the Incenter on one side, construct a perpendicular. The portion of this that is the radius is just from the center, the Incenter, to that side. Okay, so if I find that side, I can hide the reference line. And this distance right here, use Control L to find, that is the radius of my inscribed circle. So all I would need to do next is use the circle tool, the compass tool, place the compass tip on the Incenter, extend it out to the side, and that will create my inscribed circle. So once again, if I were to, again, label this, that gives me my inscribed circle. Okay, no matter where I move this triangle or these vertices, that circle will always be inscribed within the triangle. All right. Now, in addition to this, we also have the intersection of all the perpendicular bisectors. Okay, so if you were to find all the perpendicular bisectors, we'll do it in 2 pieces. We'll find the midpoints first, and then construct perpendiculars through that midpoint compared to, or from the midpoint through each of the sides. So if I find the midpoints, all I have to do is highlight each of these 3 sides. I can use the shortcut Control M to find the midpoints. And then it's just a matter of selecting the midpoint at its side, construct a perpendicular. Okay, I'll change the color of this. I'll say orange here. Okay, so my perpendicular bisector is orange. I can do that from one other side. So select the midpoint and the segment or the side, construct a perpendicular, and where these 2 intersect one another is going to be my circumcenter. So the word for the intersection of perpendicular bisectors is the circumcenter. Once again, no matter where I move these points, that will always carry along. All right, next, or actually, the circumcenter again gives you more information. It's not just labeled as that point. It is the center of a circle that passes through each vertex of this triangle. So in order to demonstrate that, if I select the compass tool, place my compass tip at the circumcenter, extend it out to any of the vertices, and you should see that it passes through all the other vertices as well. And so if I label this circumscribed circle. That's my outer one. It passes through all the vertices of that triangle. Patrick?
Lighter lines again?
How do you change the thickness of the line?
Or no. How do you just get
The perpendicular?
Yeah.
So if you select the midpoint and one of the sides, and the side, and then construct, choose perpendicular. And now, I changed my display to thin lines, but so you understand how to do that? Okay.
Thank you.
All right, now we can move on. The next point of concurrency is the intersection of altitudes. Okay, so an altitude is just a perpendicular from a vertex to the opposite side. So if we construct or select a vertex in the opposite side, and then construct a perpendicular, that perpendicular piece is going to be, let me change the color here again, change this to purple. Okay, so that gives me my altitude from this base all the way to this opposite vertex is my altitude. So what I need to do is repeat that from one of the other vertices. It doesn't matter where. So if I select this vertex and its opposite side, construct a perpendicular, the intersection of these two perpendiculars is going to be my, and the name for this is orthocenter. Okay, so that's my orthocenter. Once again, no matter where I move the vertices, that will always be the intersection of my altitudes. Okay, and then the final point of concurrency is the intersection of medians. And so a median is just a midpoint. It's the segment that connects a midpoint to its opposite vertex. So here, my constructions are already done. I've already found the midpoints. So all I need to do to find the intersection of medians is to select my midpoint and the opposite vertex, hit Control L to create my line or segment between those. Okay, I'll change this to a different color as well, which is pink. Okay, so there's one median, a vertex to the opposite midpoint, Control L to find that. And so this intersection right here is going to be my centroid, the intersection of medians. And now, because it's hard for me, I'm not sure exactly if this is going to be intersecting the correct piece. I'm just going to highlight my other median. So now my two medians are highlighted. And I can just go up to construct and choose intersection, and it'll label that intersection for me. So if it gets to the point where it's hard to determine, you can do it that way. And so now I just label my centroid. So once again, no matter where I move these vertices, that intersection will always carry along. Okay, so these are all the different points of concurrency that you need to be able to construct. Okay. You do need to be able to construct them using your construction tools by hand. And so if you have any questions on any of this, make sure you ask today when you get an opportunity. And the last thing is, if you were to draw a line through the orthocenter, centroid, and the circumcenter, what you're going to find is that if you take a line through any two of those, it's always going to pass through the other one. So if I were to highlight orthocenter and this circumcenter, construct a line, and I'll make this one dashed, dotted here. Okay, so this line will always contain the centroid as well, no matter where I move this. Those 3 points always line up in the same straight line. Okay, and that's called Euler's line. It's spelled like Euler's. You'll see it on the Sketchpad activity. But that's called Euler's line, and it always passes through those 3 points, the circumcenter, the centroid, and the orthocenter.